This is our last bonus lesson. This is our last one with variables on both sides. And this one's called all solutions and no solutions. And you'll very quickly see why that is the case. So normally when we solve an equation, we're going to get just one nice, neat answer to our problem. So here's what I mean. I do 10 times negative 4 is negative 40. 10 times 1y is 10y is equal to 2y. I'm going to get all my variables on the same side, so I might as well move them over here where the y's are already by themselves. So I'm going to subtract away my 10y. I get negative 40 is equal to 2 minus 10 is negative 8y. Divide by negative 8, and y is equal to a positive 5. So what I mean by one solution is, at the very end, we got a solution that says y is equal to 5. That means the only number I could plug in for y on both sides and get both sides of the equal sign to be balanced, to be equal to each other, is if I plugged in 5. If I plugged in any other number, the two sides would not be equal to each other. There's literally only one number that would work in this problem. But that's not always going to be the case. And this is what happens when you're dealing with variables on both sides. Sometimes something a little hinky shows up. So let's see a couple of examples and you'll kind of see what I mean. So we'll start with this one. Same as always, we kind of clean up each of the sides until we're ready to start solving. 3 times 4 is 12. 3 times 4x is 12x. And I have 12x plus 12. And you might already be thinking, Mr. McKenzie, those look awfully similar to each other, but that's what we want. Watch what happens. So we want to move all the variables to the same side. So let's say we want to get rid of them on the right-hand side and move them to the left. So I want to subtract away my 12x on this side. Well, 12x minus 12x is 0x, or 0, so I get rid of it, and I'm left with 12. But over here I had 12x, and I subtracted it away, so that turned to 0, and I'm just left with 12. Not exactly what I was expecting, but you ask yourself, does this make sense? Is 12 equal to 12? And obviously the answer is yes. 12 is always going to be equal to 12. So in this case, what it's telling us is that our solution is not just one number, it's all solutions. What it's literally saying is you could plug in any number you wanted for x, it's always going to work. So pick a number. 5. Plug it back in here. 4 times 5 is 20, plus 4 is 24, times 3 is 72. Over here, 12 times 5 is 60, plus 12 is 72. Same thing would happen no matter what number you chose. I didn't just magically choose the right answer. I chose any random number, and it works. So because there's variables on both sides, sometimes this is going to happen. You're going to get a weird statement with no x's, but it's still a true statement. So our answer is all solutions. Now let's come over and see another one. So I put my 1's in front of my x's. And we have the same idea. Let's get all the x's on the same side. So let's move them over to the left-hand side. So let's get rid of this one. So I want to subtract away my 1x. Well, that just leaves me with 3. Over here, I'm going to subtract away my 1x, and I guess they knocked each other out again, and I'm left with my 4. So same thing happened. All the variable terms dropped out, but ask yourself, is this ever going to be true? Is 4 ever equal to 3? Obviously not. That's not going to work for us. So in this case, instead of having one solution, x is equal to something, or all solutions where anything would work, this one is no solutions. Meaning there's literally nothing you could plug in for x that would ever make these two sides equal to each other, which makes sense. No matter what I put in there, if I add 4 to one of them, but I add 3 to the other, they're never going to be the exact same thing. So watch for that final piece. If the variable terms drop out, watch and see, does it make sense or not? If it does, that means anything would work, all solutions. If it doesn't make sense, if it's not a true statement, that means there are no solutions. So let's see 2 of these here real quick and kind of get a feel for how to tackle these. So this one's going to require a bunch of busy work here. So I get rid of my subtractions because I don't like those, and I want them distribute on both sides. Negative 2 times 6 is negative 12. Negative 2 times negative 10 is positive 20. Over here, I do 10 times 2n is 20n. 10 times negative 6 is negative 60. I want to get my variables on the same side, so I'm going to subtract away my 20n. But you're going to notice that not only does it cancel over here, but it also cancels out the ends on the other side, and I'm left with a negative 12 is equal to negative 60. Well, clearly negative 12 is never going to be equal to negative 60, so this is one of our no solutions. Sorry, that's supposed to say solutions, even if you can't quite read it there. Okay, let's see one more. So I do my distributive. 6 times 4 is 24. 6 times negative 1w is negative 6w. Over here, I got my 24 plus negative 6w. So you'll notice in this case, it's exactly the same on both sides. But sometimes it feels like this first one felt like a lot of the same numbers. Maybe it's going to be the same thing. I always like to make sure. So let's get rid of our w's over here. They were adding a negative 6, so I'm going to subtract a negative 6w. Well, it's the same thing as adding a positive. So it cancels out on both sides, and all I'm left with on the left is 24, and on the right is 24. This one does make sense. It is true that 24 is equal to 24, so this is another one of our all solutions. Anything you want to plug in for w, it will work every single time.